Okay, now let's recreate Ableton Live's analog device into VCV Rack. We did it once with our Your Rack case. Now let's do it in VCV Rack for free. So first off, let's see what we have. Again, let's go here next to the volume, check the quick routings. So we want to recreate this one. It's a pretty simple one. And what is happening right here, I will explain it to you once more, is that the two oscillators are summed up together and then they are fed into a filter, and from filter they're fed into an amp. It's a pretty standard subtractive synthesizer. So let's do it, but there are some more details that we will add on later on. First things first, let me tell you what we are using in VCV Rack. So we have this module. This is a record module. I'm just recording the audio of VCV Rack. This is a 4-channel mixer. The mixer's output left and right are fed into our sound card. This is our sound card module, and this is the recorder. I have put in some notes here explaining what is happening. So we will use yellow cables for audio. We will use purple for pitch or volt per octave. We will use red for triggers, gates. We will use green for clocks, master clocks, and we will use blue for any other CV that we have. And here's the scope, just in case we want to see something, we have it right here with us. So let's get started. So what we had over there was 2 VCOs. I will try to use only VCV Rack modules for the sake of simplicity and because they're mostly free. So I'm just going to type in VCO. We have this right here. We have 2 of them. So I will just right click and duplicate it. If I do it once more, I will just use the command, the D shortcut. So I will not try to use a right click. And so this is this. Let's add in, what else do we need? We need a VCF and we need a VCA. Okay, some things to mention. Here you see we have for our oscillators, we have an octave switch. We can also add that pretty easily. Let me just add this. Oct. VCV Rack has this nice one. I will also duplicate it again because we need, oh, sorry, this is the VCA, not the oct. So here goes this one. I will put it to the left of each module. So we will want to go from the output because it's going to be pitch. So I use the purple one, volt per octave. I'll do the same here. And if we have a volt per octave notes from sequencer or typing in or using the keyboard, whatever, we will use, you will have to patch it into the inputs of the oct module. So, okay, in here we said oscillators are summed up. So we need to use a mixer for this. Let's search for, again, choose VCV and then type in mixer. So this mixer is gonna do the trick for us. So I will choose the SAW oscillators. I will patch them into this. And just to show you, I'll put it here. I'll go from the output into the input. So if I choose SAW, right now you're only seeing one VCO's waveform. Now the sum of it with the SAW, with the sine, is gonna come something like this. So this was just to show you what is happening. And I will just use some for both. I will want to have this one of them I want to be 1 octave lower. So I put it right here. This one is 0 oct. So it's the base octave, and this one is 1 octave below. So let's see. From the mix, we will have to go, oops, oh, by the way, I have to change the colors of this because this is audio. I will use yellow again. We want to be consistent. Then again, we will go from the output of the mix into the input of our filter. So again, choose yellow, go from here. Now, from our VCF, we go into our the input of our VCA. Now, we can choose the high pass or the low pass filter. So for this one, we just use the low pass one because it's audio. We use this one. Let me open up the filter frequency so we're not attenuating any harmonics yet. And from the output, we will just simply go into our mixer. I think you can already hear it. Now this is obviously too loud. I will mute it for a second. Okay, so this is muted for now. Now, what should we do in order so that it's not always going out, the amp is not always fully open? So we need to use, as you know already, we need to use an envelope generator to control the shape of our sound. So I need to use an envelope generator. So let's just type in EG, short for envelope generator. Here is an envelope generator for a VCA. I will just lower the attack. We don't need this much attack. And since this is CV, we'll just use a blue cable. So I will go from the output of the envelope generator into the CV input of our VCA, which is this one. Okay, blue, there you go. Now, if I unmute the mixer, you see we are not hearing anything until I push a note. Yes. Okay, so let's continue. Let's see what else do we have. So we have a pan. We have also two LFOs. We can just use one for now. But what I want to show you is that in the filter section, right now we are seeing the filter section. You can see that we have for frequency mod, this one, modulations for the frequency cutoff. We have three sources. One is the LFO1, the second one is key tracking, and the third one is an envelope generator. So it's a separate envelope generator from the one that we have in the amp. So we can do the same thing. I'm just going to omit the key tracking. I think I explained it before, but key tracking, essentially what is key tracking is that, so if you have your cutoff, frequency cutoff, somewhere in between, somewhere here, and you play higher notes, so the frequency cutoff opens up a little bit more because it understands that you're playing higher notes, so you obviously have higher harmonics, so it opens up a little bit more. And when you play lower notes, it closes it down because you don't have that much harmonics. This is essentially what key tracking is, and I'm just going to omit it for now, but I will just add an LFO and an envelope, separate envelope for the filter's frequency cutoff. So let's just do that. We have a ADSR module right here. Let's just duplicate it. I want to put this one's right below the VCF for having more clear vision. And let's just add an LFO. And as you can see, the LFO is essentially identical almost to the VCO, and it's because they're both the same thing. As we have talked earlier, LFOs operate in lower frequency range, almost 0 hertz to 20 hertz, which is below our hearing capabilities, and VCOs operate from 20 hertz to 20 kilohertz. That's why they look pretty much similar. So now we also need, so this one is essentially showing you a mixer. Look at here, you can send positive values of LFO and also negative values for the LFO, -4, +4. The same thing for envelope, +16, -16. So you can send the inverted version as well. So this is pretty simple. We can do it in Modular. We need to use an attenuator, which was something that we had in maths. So let's just search for another mixer. This one is a CV mix. This is pretty handy. It's very much like the maths that we have here. So we have 3 channels with 3 attenuators. So not only they attenuate the signal, meaning they lower the voltage, but they can also invert the signal. And this is also an offset module as well. So if I'm not patching anything to the input of each of them, this becomes it sends a positive and negative voltage to offset a knob. So if you want to, let me show you what I mean. So I will just go through the output of number 1. You see it's just in the middle. If I increase it to the right, you see we are sending positive voltages up to 10 volts. And from the center to the left, we are sending negative voltages if nothing is patched into it. So each one can give you offset signals. All right, so let's just use the sine wave because this is CV. I will use the blue cable, and the same for our envelope generator. And now let's take a look at the mix. Because they're in the middle, it's not outputting anything. So I'll just open it up. This is our LFO. But one thing I want you to notice is that it's not going into the negative voltage range, because this is now in unipolar. Yeah, as you can see, this is in unipolar mode. It's only going up and down in the positive rhythm. If I put it like this, it becomes a bipolar LFO, which goes from positive to negative. But we can switch it if you want to. So this is what's happening right here. And it's going to mix it with, okay, let me open this one up. I will just give negative values to the envelope for now to see a different shape. Look, if I press it here, you see we're getting a new CV modulation source for our filter cutoff. So let's do it. Where should we put this? I'm just going to put it right above here, unpatch it. And so this is our VCF. And here is the CV input for the frequency cutoff. So that's what we're going to do. We're going to patch it here. The nice thing about this VCF is that it has its own attenuator also. So if it's in the center, nothing's going to happen until we put it all the way to the right. So it's setting the full signal of the CV source. Let's just do that. Again, choosing the blue color. Go ahead. And we open up the attenuator all the way up. And so if you want to send positive, you need to come down here to change that. Okay, let me see if we have everything set up. So the amp, we also have, for pan, we also have LFO. Let's just omit this. So you can do the same if you want. You'll have to find the right module. And here is the LFO. I think we set up all the necessary things for now. Let's just try to make a sound out of this. So for this one, I will use a sequencer. Because the good thing about Modular is that you can use sequencers. So let me explain to you what is happening here in this sequencer. So this sequencer has 3 rows. As you see, the first row, 8 steps, 3 second row, and the third row. The CV outputs are given here, CV 1 to 3, and there is a trig input. So take a look at this yellow LED. It's telling us where the sequencer is going right now. And with these white LEDs, we can turn on or off a step. So I will just patch from the CV1 of the first row. I'll use purple, patch it into volt per octave of this one. The same for here. I will just go out from the trig into our envelope generator. So we have a gate input. For now, I was just doing it manually. Now we need to have our sequencer do it for us. So because this is gate, we're going to use red cables. So because it's in negative, you can hear it that is closing down the VCF. Look, I will just send no LFO for the moment. So now it's fully open. Now let's send the envelope in inverted. You see, you can hear that it's going, it's attenuating the harmonics. So the frequency cutoff, it's as if it's doing like this. Something like this is happening with it. So let's keep it like this for now. Let's change our notes. I can use a randomizer also. Let's just randomize it. But it turned off some of the steps, so I'm turning them back on. The BPM is too low. Let's change it to 140. So what's happening is we have a fully functioning subtractive synthesizer. We can change wave shapes if we want to right here. We can add reverb, we can add delay, everything else, but this is a very simple one. But let's add something else. I would like to add some drums. So let me add in the 909 rack. I will put it right here. Let me make it smaller so we have better view. So I'll just go from the output into the mixer. Because it's gonna be mono, we don't need to go from the right one. It's mono, so it makes no difference. We need to add a sequencer, and I want to add another sequencer for our drums. Let's just type in SEQ. Now let's just reset the filters. We might want to use something else. I would like to use this one because it's a familiar looking sequencer. It's very close to our BeatStep Pro. We have 16 steps and there are 4 channels, so we can get a standard drum beat right here. Let me zoom in a little bit. The first row, the outputs are here, 1, 2, 3, 4, and this is the first row. I want to use it for our kick, a very standard drum rack, drum set actually. So this is going to be our kick. Let's do a snare. So this is going to be our snare. Go right here, my man. And let's do a close hi-hat, 16 steps all the way. You're not hearing anything because the sequencer is not running yet. Let me see if this is rim, so we need close hi-hat, go right there. And let's do a ride, an offbeat ride, which is going to be like this. Okay, now we need to do something right here. We have 2 sequencers, they're not in sync. What I want to do is to add a clock master, a clock module. So I'll use this one, a very nice module. I'll edit the BPM, set it to 140. So let me zoom in a little bit for you. I'll just hit run so that it stops. Now, what we want right here is, I want to use CV, you, my man, go to run so that they know when they should run. We don't have a run here, but we have reset for this one. Is this output or input? Oh yeah, this is the run also. So I'll just check, I'm not really sure, but I think this is run, yeah. And for the clock output, I'll go out from here. It's green, go to the clock input. Let's do the same thing for this one. This is clock. Okay. Now, as you can hear, it's not a 140 BPM. This is not 140 BPM speed should look like. So I'll just duplicate it to 4. That's more like it. So what we did, we added, we can now randomize it even furthermore if you want to. Pretty cool. So let's wrap it up. What we did right here, stop the sequencer. What we did right here, we made a subtractive synthesizers with 2 oscillators, just like the one in analog. We could add more details, but just for the simplicity, that's where we're going to leave it for now. We used the drum modules from VCV Rack. By the way, this is this 909 rack is not free, it's a paid version, but for the sake of simplicity, I chose it because we wanted to get something fast. And we used a gate sequencer, just like BeatStep Pro, to sequence our 909 rack, and a separate sequencer for synth. And we used a clock module to send the master clock into the both sequencers, so they are both in sync. They start together and they stop together. Okay, that's it for this one. Thank you.